Thank you for the introduction. It's great to be here today. Hello, everyone. Bonjour tout le monde. And I'll give you a little bit of context about Concordia University Library first, because that's really the context for our project. Right now, currently at Concordia, we have a downtown library that's very busy. We have limited study space for our students as well. We're a bit of a space crunch. And Concordia, because it's downtown, doesn't have a student center either. So students tend to come to the library during the day between their classes. So we have a lot of traffic. This makes the library very noisy. How many of you have noisy libraries? Would you say? A lot of you have that problem? Okay. It's not just academic libraries, I'm sure. So we're proposing this project as a way to mitigate noise problems. We've exhausted a lot of ideas, and we're really not sure what to do next. So here's just an out-of-the-box idea. And I'll turn my presentation over to my colleague, Janice.
So we're going to talk about our Raspberry Pi prototype project and how we're planning on measuring and displaying noise levels in an academic library. In the past at Access, we've seen many presentations on makerspaces and programs at libraries, but we believe that this is the very first presentation at Access about a Raspberry Pi and Arduino and how it was used to solve a library problem. So exciting. In terms of how we'll be structuring our session today, we'll go over some background information about noise in academic libraries. We'll review some of the previous studies in noise intervention. And then we will shift gears a little bit and focus on our prototype project and discuss the methods and also how it was implemented. And then we will close with the lessons that we learned for this project and also our next steps. Our goals for this presentation are to really get you thinking about how new, cost-effective, and accessible technologies like the Arduino and Raspberry Pi can be used to solve library problems and add value. And for those of you who are unfamiliar with these technologies, to help you get thinking about how these technologies may be used and how they work, and what to expect if you're planning to work on a project with them as well. So let's get started. Noise continues to be an ongoing problem in academic libraries. According to many of the LibQual surveys that were conducted across various institutions, student feedback indicate that they are not happy with the current noise level in academic libraries. And for those of you who aren't familiar with the LibQual, it is a survey that was developed by the Association of Research Libraries that measures user perceptions and expectations of library service quality. It is conducted every couple of years as part of a consortium of 47 Canadian libraries, and it focuses on 3 core dimensions. The first is the affect of service, which is the customer service of the service by the library staff. Second is information control, and that focuses more on the library resources piece, information resources, the collection, and how they can be accessed. The third dimension is library as place, and that focuses on the library spaces, the facilities, and amenities as well. And of course, the noise falls into this third dimension as library as place. And now, let's talk about, So let's now take a closer look at the 2013 LibQual survey results at Concordia University. You'll see on the x-axis, it might be kind of hard to see from the back there, but they provide the different evaluation criteria for the LibQual, and the bars, the different colors, represents the feedback from the users, where the lime green is the positive comments, blue is the negative comments, and the forest green represents the other category. The third bar from the very left is the noise bar. And you can see there is a lot of blue. So this is a problem. And as a result, we felt it was prudent to address this issue. And it's an important problem to solve also because the students are struggling with noise. And in fact, there's actually a Facebook group that was developed, that was created, called Concordia Students for Silent Blue Zones. And previously at Concordia University Libraries, they actually divided the library areas into 2 colored zones to represent noise. The blue zones were the silent zones, so absolutely no talking. And there's also the orange zones that represents the quiet study. So you can have kind of light conversations, kind of soft conversations in those areas. There was also a library feedback blog that was created to receive comments from our users and students. And as library staff, we could also post our responses to the students as well. And it was developed and implemented since 2008. And since then, we've had 179 posts out of a total of 459 that were about noise complaints. And that is roughly 40% of all the comments that we receive. So it is quite problematic. Now, let's talk about noise. Sound and noise are measured with a metric called the decibel, or dB. The decibel scale reads the sound pressure and translates the range of sound to a logarithmic scale. The range of decibels varies from 0 to 140 decibels, where 0 is the threshold of hearing. 40 decibels is your typical quiet living room space, and normal speech registers at 60 decibels, all the way up to 120 decibels, which is the sound level near a jet aircraft engine. And I know many of us, we came by airplane to this conference, so I thought that would be a good trivia point to point out. To provide additional context, city bylaws, they also have noise regulations, and they generally indicate that noise levels in residential settings cannot exceed 90 decibels. So next time, when you have that annoying neighbor having that crazy weekend party at 2 in the morning that you weren't invited to, you can take out your trusty cell phone if you have a noise app and measure the decibel. And if they are over 90 decibels, you can actually do something about it. Emergency vehicle sirens, they tend to register about 115 decibels, so that would be your ambulance, sirens, and police. And also, two things to think about when it comes to sound. There are two measurements, or we look at two things usually. First is the frequency or pitch. So whether the sound is a low pitch or a high pitch. And secondly is the amplitude or loudness of sound. And for our project, we were more interested in the loudness of sound. And of course, there are guidelines and benchmarks where organizations and agencies, they kind of set out their acceptable noise levels that they set out. And the World Health Organization, they also developed some of the noise guidelines a couple of years ago for community noise. And they recommended something less than 35 decibels in classrooms to allow for good teaching and learning conditions. And we can then translate that to the academic library setting, or any library, really, if you want to enforce these good practices. There have been a number of qualitative and quantitative studies regarding to noise, and we will only address the papers that discuss the academic library setting. So the quantitative studies focus more on the objective data, where they took out their trusty noise monitoring devices to measure the decibel level, the decibel reading. The subjective studies focus more on administering questionnaires, surveys to kind of gather the feedback from the students and the users to get their perception on noise. And when we reviewed the literature, we found that it was important to capture both forms of noise data, because objective noise data does not necessarily reflect the user perceptions of noise. And because of this, loudness is subjective, right? Because what may be quiet to one person would be extremely annoying and loud to another person. And because of this, Lieben and colleagues found that using that subjective data was actually a better measurement. Academic libraries have explored a number of interventions to reduce noise. Noise level zoning was one of the common strategies that included furniture rearrangement. In one study, researchers, they removed tables and upholstered chairs from the central area of the library and relocated them to another area of that floor. But unfortunately, they found that the reallocation produced no measurable reductions in sound. And in some other studies, they discussed the benefits of reducing clusters of furniture and to be more strategic in the type of furniture you bring in, such as carrels and cubicle-like walls to minimize group socialization. And in another library, they also separated the photocopier, the printer and photocopier rooms, and also the group study rooms away from the quiet study areas. And so they really focus on space allocation to contain the noise levels in certain areas of the library. Researchers also hypothesized that by reducing the light levels in the entryways of libraries would actually encourage users to modify their noise to be more quiet as they entered the library. And unfortunately, they found that reducing the light level had no impact whatsoever on the amount of noise that people made in those areas. There were also other noise interventions that were implemented, which involved staff monitoring by students, library staff, guards, campus security, that kind of thing. And one method of enforcement involved the staff handing out humorous cards, either on slips of paper or bookmarks, that would have statements like, "Don't be selfish, please set your cell phone to vibrate." Now, I don't know how humorous that statement may be to you, but it is a creative way of communicating with the students about their noise, right? And libraries also communicated and enforced policies and procedures for handling noise problems. And the key was to have a consistent message for the policies to have credibility. And signage, of course. Libraries put up signs, they try to be strategic in where they place them and having particular messages that were clear and understandable. And one library, they found it was important to have professional looking signs rather than something you made willy-nilly on Microsoft Word in 5 minutes, that the students tend to be more agreeable and they would follow the guidelines from professional looking signs. And on the topic of signs, we'd like to highlight a recent study that was recently done at McGill University, where they had an interesting take on the noise intervention, the sign intervention. The librarians installed an electronic noise monitoring device, and it's called the noise sign. So what it is it's an LED sign that would light up when the noise level reached a certain threshold. And I believe they originally set it at 50 decibels, but they found that it became too sensitive, that it was non-discriminative. So if any type of sound, like chairs being pulled back, the squeaking of chairs or opening, closing of zippers, it would pick it up and it would light up. So I think they then modified it to 60 decibels, but even so, when they gathered all of that data, when they surveyed the students and interviewed them, they found that the intervention actually had no significant effect on the actual noise reduction. And the user's perception of noise in those areas also did not change. The common theme across all studies demonstrates that the interventions do not produce measurable results in reducing noise. And the students responded very negatively to the interventions. Some found it more difficult to complete their work, and some students were upset with the change and felt that their personal study areas had been usurped by the library staff. And why did some students continue to be upset with these changes? Gordon, Hickey, and Lemley found that acoustic environment choice is a physiologic need, and these needs differ among individuals. So no matter what interventions we try, there are bound to be students that will not be happy, that they would prefer an acoustic environment that would be different. So rather than implementing an intervention, our proposed project is a cost-effective solution to inform users about the particular noise level, and they can then choose which environment that they want to study in or to go to. And again, just to reiterate what Pam has said, our project is in the context of Webster Library at Concordia University in Montreal. And Webster Library occupies 4 floors of a building, and we have 2.3 million visitors a year. Concordia University, we actually have 2 libraries and 1 reading room, but for our project, we focus only on the Webster Library, the main branch in downtown. And we serve a population of over 40,000 students. The Webster Library is currently being renovated, and meaning that we do have construction noise as well. So the students are very happy about that. And the renovation started in 2015 and it will end in 2018. And because of the LibQual survey results, the feedback we're getting from the library blog, and also with the construction noise, we knew we really had to address this issue. So we have a dream. What if the students, when they come into the library, they can see the noise level or get a good sense of what the particular noise level is in certain areas of the library, and they can choose the environment that they want to study in or that they want to go to. At the same time, what if the staff could check in remotely to see the noise levels in certain parts of the library and generate historical reports to identify certain trends and make targeted interventions? With these questions percolating in our thoughts, we came up with this really interesting prototype project.
So really what we're doing today, we're going to talk about our project, and we want to get your feedback on the feasibility of it, and we want to get you thinking about maybe how Raspberry Pis or Arduinos can be used to solve problems or add value at your library. So yeah, we're planning on getting the noise readings and displaying them, and we're going to demonstrate our idea and principle and show that it has some potential. And the project's not complete yet, and I'll tell you some of the hurdles we've run into. So to set the stage a little bit more, at Concordia Library, we are already displaying some live data that is helping students with services or with choosing where to go in the library. So on our website and on different digital screens that we have around the library, we show how many desktop computers are available at any certain time, how many laptops and iPads we have available for lending. In the middle, we have an image of a classroom, and the green dots are showing which computers are available, and the red dots are showing which ones are not available. I know that's not good for accessibility. We're going to change the colors. And also the last one there, we have tablets. This is brand new for us. We're using the booking system. Thank you, Michael. A little shout out. Yeah, so we have it running on tablets, and it's also web-based, and students can book a study room. They can see the upcoming bookings. They can cancel or shorten a booking. So there's some touch screens that are slowly making their way into the library. So our method is made up of a few just core items, just to give you a higher level overview. We start with the microphone. In this case, it's more of a sensor that we're using. We're using an Arduino, and I'm going to tell you the basics about these items too, for those of you who are unfamiliar with Arduinos and Raspberry Pis and exactly what they do. I think we've heard that word a lot, but for some of you here, hopefully today, this will give you a good, more practical understanding of, starting and then how you can actually make something with them. And we're using the Raspberry Pi as a web server. And we can have multiple endpoints for the data that we're generating. So for one example, Janice mentioned having a interactive wayfinding application in the library entrance, where you can interact with the map via touchscreen and find where you want to go, see if a group study room is booked or available, and check on, say, the decibel levels, and have a descriptive, say this area is quiet, this area is silent, etc. So I'll break it down for you. So we have our students there, they're making noise. And one way of doing this is to start with the microphone. So we have the microphone here. There's like a little image of a sensor there. These little things, if you're unfamiliar with them, you've probably seen little electronics bits that cost like 65 cents. But it's more of like a clap-on, clap-off kind of sensor. It's not sensitive enough for our purposes, so that was one of the hurdles we ran into. However, one of our prototypes, we've put this on a circuit, which is, for prototyping, we use something called a breadboard. So in the beginning, we can put things together, but we don't have to solder anything on an actual circuit. So it's very flexible, and you can reuse your parts for other projects. And then that goes into the Arduino. So we've created an electrical circuit. So the Arduino runs 5 volts, and we have our input and output. So you often hear Arduino input, output. That's how you're working. So you see the little black bits on the Arduino. Those you can put your wires into, and then you're running a circuit, and then basically the sensor is acting as a resistor on this circuit and sending back a change in voltage that is measured. It's not, at this point, it's not a decibel level, but we can make a table of values and translate it into that. And Arduino, what is it really? It's a microcontroller. What that means, I can think of a couple of examples that'll give you a better idea. You could think of a vending machine. So a vending machine, maybe there's even a couple of microcontrollers in there. You have sensors that are looking at the coins that are being entered into the machine, maybe weighing them, checking the size. There's a light sensor when the coin is rolling down to see how big the coin is. You have an output, like an LCD screen showing how much money you've entered into the vending machine. A treadmill, for example, doesn't need a computer to run, but you have inputs and outputs. You have buttons that are push buttons that are added onto a circuit and that can change what the information is sending, and you can attach motors to Arduinos, run a fan, run anything really. So, and then we go to the Raspberry Pi. So how I did this, and my background is really more in the arts and in visual design, and I like to think of myself as a bit more of a CSS person. Well, I'm pretty good at CSS, and I like PHP as well. So I didn't have any experience working with with this physical computing, but I do have some troubleshooting skills and understanding of programming. So I hooked up the Arduino to a Raspberry Pi because I had these two items. And the Raspberry Pi is different from an Arduino. It's actually more like a mini computer. So what you do when you have this credit card size bit of electronics, there's an Ethernet plug in it, and you can plug it into your computer. You can also or by itself, sorry, I'll back up a little bit. You plug it into a screen and a keyboard, and you boot it up, and you have an interface. So it's almost like, it is like a little mini computer. It's running a version of Linux. It's a little bit slower. It has some programs on it. You're not going to be able to install, say, Microsoft Office on it, but there's other things you can do, and it's all open source. And one of the things that you can install on Raspberry Pi is Python. So Pi and Python go well together. And we are also using Flask. So Python by itself, it can do a lot of things. It has its standard library, but Flask is a web framework. So it's another additional, like an add-on to Python that lets you serve up web pages and have the Pi be a web server so you can put content on the web. And and so at that point, then we have content to put on the web. So actually I didn't do an HTML page. What I did is a JSON file, and I'll show you an example of that. It's JavaScript object notation. It sounds a bit scary, but it's really nothing special. And from there, you can do all kinds of different things with it. So one of the things, we can write it. I don't have to put it in a database. I can write a text file that I can use later to generate reports, or put it into Tableau, put it into Excel, use R to compare it to other information that has timestamps at the library. We can also get the JSON using JavaScript and AJAX and jQuery. So AJAX are just instructions for how JavaScript can interact with the server asynchronously. And jQuery is probably the most common library that you would install with JavaScript. It's used everywhere, so it adds some. It makes JavaScript a lot easier, And it helps you do some animations and some more interactive type features. And so once you have the JSON file, really, like you're good to go, and we could display that information in an interactive wayfinding application too. So the microphone. So the microphone sounds simple, not so simple. The proper sensor is a key to the project, and we want to have something that's going to give us accurate information, but we don't want a standalone microphone. Maybe we could hack something like this and add it and put it into the circuit. But we've tried a few different sensors. They're not giving us enough information quite yet, so if you have any recommendations, let me know. We need to be able to send information that we're gathering from the microphone to the Arduino so that we can include that information later. Okay, the Arduino. So before this project, I didn't really know anything about the Arduino, but what I would recommend for those of you who want to get started, there's a great book, Getting Started with Arduino, and if you Google that title, you'll be able to download the PDF of it. And it starts with all kinds of example code you can copy and paste and have a little diagram to set up your circuit, maybe with your LED light that you want to blink, or add a little push button and have it work there. So that book is really great. It's about 80 pages. And the microcontroller, it's like a mini computer, except that it has one purpose, and it runs a program on a loop over and over and over again, as long as it's turned on. And that's an image in the middle of Arduino, and then beside it there's a breadboard. That's what it looks like. And it's all open source, and it's open source hardware as well, so people build their own versions of the Arduino, and there was a presentation the other day about that, and they can still use the software that Arduino supplies for sending information to the Arduino, uploading their program. So here's what this is. It's what is called an integrated development environment. Here, I just wanted to show you a screenshot. You might not be able to read what the code is, but to give you an idea, this is only a few lines of code, but you've got everything you need there to do the serial communication. So we have a little clock running. We're saying we're wanting analog information instead of digital information, and we're writing that analog information, and then we set a delay of 1 second. And so there's 3 main parts to each little Arduino program. So just want to demystify that. That's how it works, basically. Further on, we're looking to add an Ethernet shield to the Arduino so that it can have its place on the network, and we can send data over the network instead of having like a one-to-one Arduino to Raspberry Pi. We can have multiple Arduinos, and that will be cheaper that way. You can do things wirelessly, but in the context of the downtown library, I wouldn't depend on the wireless signal for keeping these systems up and running, but that does exist, so you can make things wireless and then connect. So what is a Raspberry Pi exactly, and what is it doing in this project? Well, it listens to the Arduino and it gets the sensor values. So to read the serial information from the Arduino, we import a little a Python library. We add a timestamp, and we use Flask for outputting the web page. So in fact, the little Raspberry Pi is serving as a web server. So Python, Flask, JSON, Ethernet cable, or Wi-Fi connection. And there's tons of documentation online, and there's other sample projects as well that, while I was learning how to do this, I looked at instructables.com. I looked at some books on Raspberry Pi, on Arduino. I looked at some Python programs, and so I was able to mash together something here. It's probably good that those of you in the back row can't read my code, but it works. And this is what the Python code looks like. Python is quite powerful, and you can do tons of stuff with it and solve all kinds of problems, so I recommend it. But yeah, that's all it is, and just to demystify that. In fact, I don't know how many of you have seen Mr. Robot, but I'd like to say Darlene, she had a script that was going to take down the worldwide baking institutions, just the Python script. And there's also a Raspberry Pi in there too. They had hooked up to the heating system. That's just season one. That's just season one. But I didn't say exactly what happened, right? It's still a secret. This is JSON. So here's JSON. That's all it is, really. It's just a name-value pair with the curly brackets and some commas and colons. So that's what my web page looked like that I was sending. In terms of implementation plans, what we want to do once we have our proper sensor is to take this JSON file and output the content in real time on screens in the library. So that students can see the screens and they can have an idea of what kind of environment that they want to study in. Because I think overall, just saying that we want a quiet library, it doesn't suit everyone's purposes. What we need is different environments for different types of students. And I think we can maybe achieve that with this. We can generate reports. We can put our information on the web in any other wayfinding application that we have on touch screens. So that's that. So lessons learned from us, basically, I would say, everyone talks about Arduino and Pi as, hey, I worked on it for like a few hours and I got something going. I would say it is relatively easy, but then you run into little weird things. So for example, working with the terminal, so knowing those commands in command line and configuring the IP for my Raspberry Pi and these kinds of things that if you don't have a computer science background, or if you're coming from more web development like me, I had an idea, but then I had to kind of uncover this stuff for myself. So it can be a little bit time-consuming. However, there's tons of information online. Google is your friend. So it can be time-consuming for newcomers to troubleshoot. And that concludes our presentation. We're a bit early. But to get you started on some discussion questions, for those of you who are new to Arduino and Pi, do you think you've warmed up to the idea of maybe trying these new technologies now? For those of you who are more experienced, who've maybe played around with Arduinos and Raspberry Pis, do you think our project would work? Why not? And for all of you, do you see other opportunities for using sensors or microcontrollers in your library or daily life? I know maybe a temperature sensor could be something that would be useful in a library. So,
I'll grab the microphone and bring it around to anyone who has a question. Just raise your hand, I'll bring the microphone to you.
I think I might forget my question by the time the microphone gets here. No, sir, first of all, I wanted to answer your question. I played a little bit with the Arduino, and I'm impressed by how you've connected all these technologies. It's one thing to learn one, but to learn a bunch of them. Now, my question is more, have you thought of talking to the people? Do you have like an electronic music group? I mean, Concordia, you've got the computation arts people.
Yeah.
They seem to me, I know we have somebody in music who does all sorts of stuff with Arduinos and something like that. They seem to me the sort of people might know where you can get cheap microphones that are accurate, especially if there's somebody who does field recording and stuff like that.
that's a great recommendation. And yeah, we do have a great computation arts department at Concordia. So yeah, I'll definitely look them up.
Any other questions? If you see someone with their hand up, let me know. Over there? Okay.
I'm interested if there are any special security considerations in putting devices like this in public spaces. whether there's anything different in using Arduino and Raspberry Pi and hardening them against intrusion than other more commercial off-the-shelf products.
Yeah, that's definitely something we've been thinking about, and with all information technology in public spaces, there are risks. For example, we had a situation with keyloggers at our library, so we've had to block off access to the backs of computers and have that all locked down. What we do have is, and of course too, getting access to the network in those areas as well. There's a security situation, but I think what we could do is build it in together. What I was thinking is about, often when you go to a museum or an art gallery, they measure the humidity in the room. So to have something similar to that I think that would probably serve our purposes. And also too, like in terms of, we're not recording any kind of sound. We're just sampling the amplitude. So then we're not really, there's no spying or anything involved. But does that answer your question okay? Sure. Yeah? Okay, thanks.
Anyone else like the microphone? Any questions? Okay, well then how about a round of applause for Pamela and Janice?
We also have our bibliography site and recommended learning resources, and we'll have our slides available for those who are interested. So thank you.
Thanks.